All right. I went to the store today. It's the next day, and they did have some of those little square fuses. So I bought. They sell them in threes. I got a 10 amp version and a 15 amp version, which I think are the ones in here. Now, if you own one of these, don't do what I did last time and take it all apart. Just take the 4 screws out of the front, and then when you take the front cover, get my fingernail in here. There we go. So the front cover just flops out and you can get to the fuse. So that's the easy way to do it. I need to change the batteries on my mouse. It's giving me a red light. Last night, since I couldn't go to the store, it was bugging me that I didn't know the root cause. Still don't, but assumed that fuse was going to fix it. I really wanted to prove myself that fuse was going to fix it. So in the old days, you might wrap the fuse in aluminum foil, which would be a bad idea. But what I did, and I don't know if it's going to show on camera here, but I put a little bit of 30 gauge wire across the fuse. Now this is supposedly a 10 amp fuse. I don't think 10 amps is going through a 30 gauge wire, but without a load on the machine, this should probably be reasonable to see if it's going to work or not. And it did seem to work. So I'm encouraged that popping a new fuse in will actually fix it. So let's do that now. Get one of these fuses out of its bag. The cool thing of these fuses is they come on tape and reel because they're so darn tiny. Let's see if I can't lift one out of here. Oh, this is a really nice one. It has little gold contacts. This looks much higher quality than the one that I took out of there. They had the handwriting on it. Yeah, this one has a printed 10 amps on it. So I'm gonna say we are probably good to go. Let's see here. I think I want to use the hemostats. That seems to work the best. All right. Pop that sucker in there. Yeah. All right, so let's plug it in. Is it turned off? Yeah, it's turned off. Plug it in. Pop the front back in. And give it a go. Nothing. Yep. There we go. Just had to wait for it to boot. There we go. Looks like it's working again. So I think that's all that was wrong with it. Yeah, everything seems to work. Run stop. Uh-oh. Oh, maybe not. What happened? What happened? I hit run stop and it died. Uh-oh. Yeah, it's dead again. Uh-oh. Uh-oh. That's not good. That's not good. Let's unplug it. Let's see if that fuse blew. It might be dead. Yep, that fuse blew. When I hit run stop, turned on the output. So I'd say this thing's toast. Well, that's too bad. I kind of like this thing. Test it out here on the bench. Yep. Well, it's worth a shot. It was fuse protected, but it died anyway. Let's check the other fuse, see if it's still okay. Yeah, the other fuse is still okay. It happens to be this fuse, so this means there's something in here that's dead. There's these power things up here They could be dead. Of course, you're never going to get schematics for something like this. Yeah. Just going to be shooting in the dark trying to fix this thing. So, I think it goes in the trash can, fortunately. Wonder what it could be. Something crowbarred. I mean, it could be all kinds of stuff. But turning it on blows that fuse. But I don't know what that fuse does. I don't know what that protects. How could it draw 10 amps? Right? Yeah. It does seem strange. What would be the output? See, if something was on the input, drawing 10 amps. I guess the switcher, I guess if one of these FETs was shorter to ground, I guess we can at least go one step further since I'm going to throw it away anywho. We can see if one of those devices is dead and replace it. And I guess that's a reasonable thing to do. We will take a picture so we know. I mean, I just took a video, but I'm going to take a picture so I know where the pluses and the minuses are. Take the wires out. Usually in troubleshooting things, it's the big heavy duty things that are the ones likely to fail. And there's some FETs over here next to that fuse, and there's some FETs over here next to that fuse. I'm going to say it's those guys. Those guys are the most likely culprits. So, all right, I've removed two of the components. Here's one of them, and I will do a test on this one. And it comes up as a NMOS, N channel wacka wacka. All right, so he's good. And where did I put the other one? It was right here. All right, this one has escaped onto the floor. Let's put him in. Test in progress. 2 resistors. That doesn't sound good. A 59.1 ohm and a 0.2 ohm. Yeah, that might do it. What is this device? What is he? Where's my magnifying glass? I just had it out. Here it is. NCEP039N10. Yeah, let me type that into my phone. Yeah, this is a .ru website. It is 100 volts, 135 amps. Woo, it's a bruiser. Wow, 135 amps. I don't think I need 135 amps, but on resistance, blah, 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 blah. Wow. Wow. See if I can find a replacement for that one. I've got a bunch of MOSFETs that are heavy duty that probably will be okay there, but yeah, let's investigate. Well, we have a bad part. These two parts were identical. They are from this Chinese company, CE Power, and 100 volts, 135 amps. Whoa, 135 amps. So they're pretty cheap. I could buy some, but it would take a while to get here. I looked in my junk bin, and I found a IRF 540. Now, if 540 is 100 volts, 20 amps continuous, 110 amps pulsed. So I'm going to pop him in there and see if the thing comes back to life. And if it does, then I know that's the only failure mechanism, and I will then order some of the matching parts, and I'll replace both at the same time. But right now, I'm going to put the good one back in. I'm going to put the 540 back in, throw this guy away, and they put their little heat sinks up back. I got to remember that. So, yeah, let's do that. When you're soldering parts on like this, make sure you attach them to the heat sink before you solder them on, so you don't put any undue stress on things. Now this part has its legs bent, so we will unbend those. All right, nothing to lose. Give it a try. I replaced the fuse, put the other part in there, turn it on. I've got the display hooked correctly. Okay, everything's looking good. That one works good. Okay, let's hit run stop. And there we go. It's working. It's not working right. It's 11.12 instead of 12 volts. So that may be because it's the wrong part. It's not drawing any amps. It is drooping down. It's probably just because it's the wrong part. But I think I know enough right now to go ahead and spend money and get the right part to put in there, because it's not blowing the fuse. So turning it on, it's just drooping. So turning it on is probably working, and it's taxing that part past its, it's probably heating up, right? It's probably getting hot, because this one's rated, this one is rated a lot better. What is the, this one is 3.5 milliohms. How much is this one? 77 milliohms. Yeah, so that's what it is. It's heating up. This has higher temperature, so it's heating up. So I am pretty confident that if I have the right part in there, I can fix it. So that'll be a different video.